Good morning everyone. I am Saurabh Ghosh from Silver Model High School and I am here with my model which is a digital water computer, a computer which will able to do all our computational operations, addition, subtraction, multiplication and division with the help of the flow of water. So let me introduce to its parts. So let me tell you what are the parts here. So first part which we have here is an half adder, and rest which we are continuation are the full adders. The next part which we have are the complement section, which is our dissection, and the last part which we have is our storage section, which are dissections, and the last but not the least our drains. So now let me show you that what are the gates present here. So the first gate for this which will be able to do this digitalized operations are our AND gate. So what is an AND gate? AND gate is a gate when both the binary results are true, it will give a true result only. If any one is false, it will not execute its correct result, and that's way it will be able to do the section in this section. In this section, we will be able to do the AND operation. And what is an OR section, which is our another gate? When any one result is true, it will be able to give the correct answer, which is our 1, which is able to do with the OR section. So we have two gates here, AND and OR, but by mixing both, we have even included one more gate, which is an XOR gate, where what happens is when we have one binary answer correct and another answer also correct, it still gives a nil answer, and when any one is correct, it also gives a one answer. So that's all over how it all together works with the help of an adders, and by making all these gates giving a proper position and vice versa. So this will be able to do our addition. To give an assist, we have made our complement section. So before we say our complement section, let me tell you our the quantum flare present in this computer. The quantum flare present in this computer is the first thing which I will tell is are the Pauline's flipping gate or the Z gate, which will be able to flip the numbers or the binary numbers from 1 to 0 and 0 to 1. The second thing which we have used here is superposition. Superposition is a point when both the results 0 and 1 are actually coexisting together at the same time. That is only our superposition. And what is the entanglement, which we have also used here? So entanglement is a position when on one railing, when the answer is there, the answer is also present in another railing. Means if it's something is present in this curve or in this section, it's also present in some other section in other place. That's why we have this entanglement procedure. Although for not, let me tell you that this is not a quantum computer. Why it's not a quantum computer? It's not a quantum computer because we are not using any quantum particles like electron, protons, neutrons, photons, and etc. We are not using any of them. We are just using the water molecules in this, so we can call it a molecular entanglement in this case, and it's all done with the help of the water molecules. So water molecules are able to do all these operations. So let me tell you about how it will do it. So this will do complement section, and this will do the addition process, which will be able to make our calculations of subtraction properly. And what about multiplication? The repetitive adder will also able to do our multiplication properly. And also we have made one more section, which is the storage section. Storage section are the parts which will actually give the storage, like actually the computer is having only the 32 bits capacity for 32 decimal calculations, but for further calculations we have used a ROM property, which is actually our storage section, which will be having a 32 bits continuity of the like calculations with a hereditary order, which is our like a digital representation of some of the Unicode systems or the ASCII type systems, but this is not that. This is a different type of encoding scheme which we have made of 32 bits, and we'll able to do calculations vice versa, similar to this digital section. It's almost the digital or non-digital. This is a hybrid section, or the person who will not in much in the contact with the digitalized versions, he or she will able to actually do addition in this curves till the honor section, and also take some counter for the division. So what happens is this actually each has a 32 ml bits. So what these 32 ml beads are doing? The 32 ml beads are actually able to having the increasing orders. So when we are actually putting more 32 in this section, it's actually increasing by the time, and when it's increasing by time to time, it's again flow off from this section, and then again it fills up and this goes on. So let me introduce what are the parts. Our first section is a zero gate, which is able to take till 32, which is our max capacity even here. After this, if it is overflow, it gives the storage to this section, which is our cup. So 32 altogether in decimals makes 1 cup, and when it's increased up, it again makes one more. Means cup means when 0 to 32 first is complete makes 1 cup. Again 0 to 32 again gets away and makes it 2 cup. And 64 is equals to 2 cup, and it continues till 1024 times till it is and completes the car section. And when car gets over 1024, it's actually making 1 cup. Okay, so you can verbally put the water in these sections and actually do the calculations to the higher limit up to the 10 crores. So this is only our capacity in this field. Actually, it moves to the under section. And the second part which we have made here is the storage for the also for the division counter. So counting for the division. As we all know that the multiplication is taking place, so we have put the counter for the division to count that how many can it's actually like its question is. So to count the question and also sometimes to keep the remainder, we have actually made this division section. So this is how it will perform actions in this computer: addition, subtraction, multiplication, and division. And let me tell you that what are some other things which are these drainage systems. So we have three drainage versus the lower drainage, middle drainage, and the largest drain, which is our main drainage. So we have made some drainage system. So in this case, actually while doing the digitalization, we have actually the flip of these adders in this downer section, which is actually in the another like in the horizontal section, which actually we have put in vertical section. So we will be putting the calculation of the additions in the accordingly per the adders in that horizontal section. So the calculation doesn't get misspelled. So we will be starting with the calculations right now. So first is our addition. So we will be adding two numbers, 2 plus 2, which is our 4. So in 2 plus 2 here, in this case in binary, is 1 0 and 1 0. If we put 1 zeros of the both this section in differently, so let me see where it actually reach. It should reach in this section, which is our fourth cup. So here are the 2 cups, 4 cups, 8, 16, 8 and 16 cups is the final thing. So we will be putting 1 to 4, so it must enter in this fourth section. So we will be putting water 1 0 and 0. So as per the zeros of the binary sections are zeros here, and the ones of the other two sections will actually reach here because the 1 0 and 1 0 property of the adder. So let me see and put the water in this section by putting in the vowel order. So let's see with our calculations. And here also we will be discussing about the rules which are actually there for these calculations and how about the performance. Yes, it went correctly. The calculations went correctly as the water has actually reached our fourth cup, which is actually our 2 plus 2, which is 4, has given answers very correctly. So you can see the answer is in the fourth section. By performing which we can say that yes, 2 plus 2, which is 4, has been given correctly in this section, as the answer is actually present in the fourth section, which is the final water present here. So we can pause that what else will give the result. So our answers will be correct. Yeah, so it's actually the calculation process has stopped and has actually reached to the section of D2. So it's done, we have done our addition in the digital form. So it is good enough and you can see that it's done properly, and yeah, the calculation is over finally. It has processed it and it's actually in 4. Now many will actually question me, why still water remaining little bit water in 2, but as per the law the largest number is actually the answer for this case. and we have got our correct answer 2. Actually, the fourth section of water is also present in 2, which is only our called entanglement, which I have actually explained. The presence of water, actually a calculated form of the digital footprints in the another place, is also entanglement. So the water is entangled, so it's gave a correct answer. It is 4. 2 plus 2, which is 4. We have got our answers. So we can actually now do one more addition, plus 1, which is 3. So let's do, we will be able to do. So 2 is our 1 0 and 1 is our 1 in binary. So let's do, will it be able to calculate or not? So it's time for our 2 plus 1 is 3. So as per 2 plus 1, so it will actually reach the 1s and 0s and in one section. So the water will be 0 will reach here and 1 and 1. Too much, I guess. This is too much. Yes, till now our answer is getting correct, which is 2 plus 1 is 3. I guess I must lock it. It's getting overfilled, so I am open in many other sections. So as per to see, our answers went correct, which is our actually 2 plus 1 is 3. So 2 plus 1 is 3, which we got actually correctly. It's 2 plus 1 3. It gets correct answer, which is our second rule. So first one which we did is actually a rule of odd addition, and the second one which we did is a rule of, first one we did is the even addition, and the second one which we did is the odd addition. So for the rule for the odd addition is, suppose we have 1 2 3, so which whenever the answer is odd, it's actually the whole of the sum. But sometimes for the entanglement and coaddition, sometimes you may get shuffled in this case, so be quite calculative in this case, but our answers will come definitely correct, which is in this case also we got the water molecules are present in 2 section and 1 section, so 2 plus 1 3, and also 2 plus 1 which we did binary, so definitely 3. So to see, actually you will not notice that actually these are actually binary results also. If we had 1 0 plus 1, it gives 1 1. So 1 and 1 and rest all are 0. We got our correct answers. And if we ask for the superposition, if you want the answer also in binary also, in earlier section, which was our 2 plus 2, which is 4, you will notice that it was in the 4th section, our water, and rest this was totally empty, and this was 2 because of the entanglement, but actually 0 and 1 exist 2 together as per superposition, and due to what entanglement present, which was not actually complete presence. So for that reason, it's actually 1 0 0 also, which is also 4 as per binary. So we got the correct answers both the time, which is our 2 plus 2 is 4. So now we will move to subtraction now. So we will be doing our subtraction in a binary in digital form. So let's start with our subtraction. So we will be subtracting two numbers which are 3 and 2. So 3 minus 2 is 1. So we will be proving it by this of this water computer. So 3 binary is 1 1, which we have already discussed, and 2 is 1 0. So for first rule of the double complements rule is that first 1 0 1 1 1 will actually convert. So we will be taking 4 bit for this section, this first 4 bit section, which will actually make the complement. So which we have 1 1 will actually get reversed to 0 and 1 respectively for now. So let's start with that. So make sure of the table syringe which is there, we can actually set up here. So first thing which will happen is the 1 1 will actually become 0 and 0 is nil. So actually because of superposition 0 and 1 exist together, but we will be putting accordingly when required. So first we will be putting 1 and 1. So first one which will actually make it 4 in the beginning section. And now let's make it 3 by putting one more in the 10 of water. So let's do it. after putting the water, it has become 1100 as I see. So now which is we have a 1's complement. So as for 2's complement, we add 1. So let's do our 2's complement for now. 2's complement. So now it's finally 3 with some negative. Before that it wasn't 3. It was 12. Now it's 3 because of adding that 1 in negative. So now we can add 1 0. So we can add either in digital section or this section, but I prefer bringing it in this section because this is much preferable area. So in binary we have 1 0 which is 2, and if you add 1 0 it will actually make it 1 1 1 1. So let's put that water 2. And fall down. Sorry. So I have put 1 1 1 1 by adding all the ones in this section. So it's 1 1 1. So actually the thing is that the complement section reverses that, which we have seen last time also. While doing the tree 1 1, which was here 1 and 1 somewhere here, has actually shifted here into 1 and 1 in different plot and zeros in this section. So 1 1 here has become 0 and zeros here have become 1. So that's the thing, it reverses. And as because all of these are zeros means now 1, so after coming here it will become zeros, so it becomes 0 0 0 0. And now if we add 1 in it, which is actually the last part of our complements rule, by adding 1 which will give us the real result 1, which we will be doing now. So its subtraction is going correct now process, and this is our final process to be done by the adder itself. So let's see how the calculations went off and see how it will be able to do the calculations. So I guess this is the correct answer which we got as 1. So the question is done properly by it. It's done by the calculations. So we got 3 minus this 1 is our subtraction section. So now we will be moving further with our multiplication in a digital form, and now we will be doing the multiplication, which is 2 3s are 6. So if you do 2 3s are 6, actually the thing is that for multiplication we have repeated adders. So 2 plus 2 plus 2 is also 6. So we will be making it 2 3 6. So for that reason 2 3 6 is how we will do this. We will take 1 0 1 0 1 0 accordingly, and we will try to get 4 plus 2 6 in this section, which will give our multiplicative answer of 6. So we will be doing so. So let's start here. So we will be putting the water now. So one side here, one side here, and final. So let's see, 2 plus 2 plus 2 6, which let's give the. So this even shows that we can do the repetitive functioning of this computer. It also represents that. So it's time finally, yeah, it's been correct, which is 4 plus 2 6. Yet now it's correct. Let's see how it calculate further. And the water must reach out in this case. Well, it's too much. There's too much of water, so I actually cleared it out, but no problem. We have a correct answer, which is 4 plus 2 is 6, which is the correct answer, and we have got our correct answer, which is 4 plus 2 6. And now we will be actually taking a counter from any section. This is our division section. So we know that 4 into 3 is 6, which is its correct answer. But now let's take its calculations in a different form, which is if we take 3 2 is 6, and that way then we can actually see 2 divided by 6, which gives 3. So 2 3 6. So 3 is actually the quotient. So we can take the quotient now for this, but the additional help for the division which can be kept in the storage section cups in our room. So it's time to keep it here. So be careful while taking the measurement from these syringes. Okay, so I Actually, I didn't just too much time. So let's get the calculations. Some more point. Yeah. We got 3 here and we can put it from this section. So you can even measure here, but I prefer you measure in the syringe. And it keeps the water in that section. That's it. So we got our thing is 2 plus 2, which is 4. Sorry, it's 2 plus 2 plus 2, which is 6. And we got our section of division, which we will get as 3. So it's all done of our 4 operations: addition, subtraction, multiplication, and division, very nicely in the digital form. But as I mentioned earlier, the storage section itself can do one more way of adding calculations. So we will be doing right now that. So we will be not pausing and we will be actually making these sections calculations. So first we will do the addition in this section. See, this is also digital form, because digital means when one thing has some value in a smaller particular portion, so it actually has. So we can call it this is quite digital, but not properly digital. So now let's start here. So we will be adding, see, dealing with large number in this section is quite tricky, but not for this section. We can deal with larger numbers very easily in this section. So let's put the water. So let's do one simple thing. 10 plus 10. That will be quite simple. Let's go with 10 plus 10 or 10 plus. Okay, let's go with 10 plus 10 only for now. So 10 plus 10. So see 10 ml and see will reach it 10 ml or not. Yes, you can see it reached 10 ml. So now we have to add one more 10 ml of water. See that no bubble is inside, or else the calculation may differ. So I guess we got the correct answer. Yeah, it's completely 20. So yeah, we got the correct answer in the addition section, which is 10 plus 10, 20. But now let's do subtraction with the help of these cups. So let's subtract 9 from it, so that we get 11. Let's try. So we have to take it and actually extract some water till the level of 9. Yes, we did it to what level? More we need. Yeah, it's 11. We got the correct answer. It's 11. So be careful while doing subtraction for this cases. And we will easily do multiplication in this section if you can do addition easily. So let's take 10 3s are 30 for this section. Let me clear this out. See, you can clear it in many ways. You can either use your rejections or you may open these sections so that you can clear it off. So let's put the water. So let's do 10 3s are 30. Since 10 plus 10 plus 10. So this will be doing with the not with the binary system, but instead with all decimals, which are 32 base encoding. So we'll be adding 3 times 10. So 10 and 1 10. And 2. And now finally came 3. So we got 30. So now see, we may need to keep the remainder properly. So for that section we will be using the thing. So let's take a counter. So if we add 30, which is is our 30 and 10 will be divide. So what is this? 10 3s are 30. So we can now keep the counter of 3 in this section. So it's fine to keep it. Take the measurement properly before you use. So let's put the water. And here you are done with the division section. So division is done. So we have shown all the addition, subtraction, multiplication, division, and the rest of the things and what, how, and how this session of our quantum computing and also our credit to base encoding and digital computing, which we have shown with the help of our model digital water computer. Thank you to all present out.